lesson 7.3, special products of polynomials. You should be on page 372. In this lesson, you will learn the square of a binomial pattern, how to use the sum and difference pattern, and then how to use these product patterns to solve real-life problems. Let's talk about the square of a binomial pattern. They call these patterns special because they're shortcuts, okay? The square of a binomial pattern. So let's think. A binomial means two terms. So here would be two terms, a plus b, and I'm squaring it. Now, let's do it the long way first, which is to double distribute. So if I want to double distribute this, I'd have to write a plus b times itself. I'd have to do, and now I have to double distribute. Let me highlight here. So I got to take a and distribute it through. So let's do that. A times a is a squared, and a times b is ab. And then I have to take the second term. Remember, it's a binomial. I got to take the second term, and I got to distribute that through also. B times a is ab, and b times b is b squared. And I would get a squared plus 2ab plus b squared. Okay? If this was a subtraction, let's quickly go through that. What if I had a binomial squared that had a subtraction? Well, it's the same process if we double distribute. Double distributing is, I guess you could say the long way, a times a is a squared, a times negative b is negative ab, and then negative b times a is negative ab, and negative b times negative b is positive b squared. Now, let me write this out. Simplify a squared minus 2ab plus b squared. Now, I want you to notice, look at these answers. They're exactly the same, except the sign, let me highlight it in green, matches the sign that you started with. So here I had an addition, and I had an addition here. Here I had a subtraction here. So what's the shortcut? The shortcut's the following. Instead of double distributing, when you have a square of a binomial, you can do these three quick steps and you're done. You can square the first term, square the last term, multiply the first and last term, and then double it. So if you're like, what? Okay, let's look at this example. Okay, let's square the first term. Okay, there's the first term. 3x squared would be 9x squared. Now square the last term. Let me color code here. We'll square the last term. The last term's 4. Let me square that. 4 squared, 16. And then the last statement is to multiply the first and last term and then double it. So I want to take 3x times 4. 3x times 4 is 12x, and double 12x, that would be 24x. And then let me just write this in proper descending order. I'd have 9x squared plus 24x plus 16, which is what you see here. Okay? So you can follow these three rules, and in 3 steps you're done, where if you double distribute, you have 1 calculation, 2 calculations, 3 calculations, 4 calculations, plus simplifying. You have 5 steps, where if you follow the shortcut, it's 3 steps. You've just cut out 40% of your work if you can remember the pattern of a square of a binomial. Okay? So that's why it's nice to know the shortcut, because you cut out your steps, and if you cut steps, of course, you're probably reducing your chances of making a mental mistake and so on. We talk about that a lot in class. Okay? Why don't you try, these are all binomials squared. You try the 3-step shortcut on these. Now the good thing is, if you forget the shortcut, you can always double distribute. It's just you're doing it the long way. So go ahead and pause the video and try those. I'm back. You should have gotten these responses. So here's 1, there's question 2, question 3, and question 4. If you did not get that, make sure you ask in class. Here's the second shortcut. It's called the sum and difference pattern. So here would be an example of 2 binomials. Can you see how one is an addition, one's a subtraction of the same things? Sum is addition, right? Sum means add, difference means subtract. So if we're adding and subtracting the same things, there is a shortcut. First of all, let's do it the long way. I'm going to do a times a and a times negative b. I'm just double distributing. Then I'm going to do b times a and b times negative b. And then do you notice minus ab plus ab cancel out, and I'm left with a squared minus b squared. So again, I had to do 5 steps. I did 1, 2, 3, 4, simplify 5. This is a 5-step. You know, if you double distribute, it's a 5-step process. Here's the shortcut. You multiply the first terms together, you multiply the last terms together, and you subtract them. So again, you've cut 40% of your work if you remember these 3 steps. So let's try that down here. Multiply the first terms. Well, t times t is t squared. Okay? Step 2. Multiply the last terms. 5 times negative 5 is negative 25. So I put subtract them. You just minus 25. There you go. Okay? I guess you could really think about this as just 2 steps in a way, because we're going to end up subtracting every time, because positive times negative is negative, and there's your subtraction. Okay? I guess I could even say this is really a 2-step shortcut. You would actually eliminate 60% of your work. Let's do it on one more, okay, just so you can see it at work. So first step here, multiply the first terms. Do you notice how we're adding and subtracting the same binomial? 3x times 3x is 9x squared. And now the last terms, got to multiply those. Y times negative y is negative y squared, and there it is, you're done. So I guess we could even say this is 2 steps. You're cutting out 60% of your work if you know the shortcut. Now this is kind of nice. Sometimes you see me at the board and people are like, how did you do that in your head? Okay. Sometimes I'm using these special products to do a harder problem in my head, like 26 times 34. Now, I don't know what 26 times 34 is, but I could think of 26 as 30 minus 4, and I can think of 34 as 30 plus 4. Do you notice how I have the sum and difference of the same binomial? Now, we just learned in the previous slide, there's a 2-step pattern for solving that. So let's do it. Multiply the first terms together. This is easy now. 30 times 30 is 900. And then if I take the last terms, which would be negative 4 times positive 4, that's negative 16. And 900 minus 16, I should say, is 884. So yeah, there's no way, even as a teacher, I don't know what 26 times 34 is, but if I think of it as 30 minus 4 and 30 plus 4, that's easy. Or look at this one. We'll do this together. I want you to find 21 squared. I don't know what 21 squared is off the top of my head necessarily, but I could do this. I have 20 plus 1 times 20 plus 1. See? That's now a binomial squared. So remember the shortcut. Just write it this way. The shortcut is to square the first term. 20 squared, that's easy, 400. Square the last term. 1 squared, that's 1. And then multiply 20 and 1 together, that's 20, and double it. That would be 20 doubled 40. This is 441. If you take your calculator and do 21 squared, you get 441. Why don't you pause the video and try numbers 5 through 7. And we're back, and here are the answers you should have gotten for 5 through 7. Again, if you were not getting those, make sure you ask when we get to the beginning of class time. You can also solve real-life problems with these special patterns, and there are real-life situations that involve these special patterns. A combination of 2 genes determines the color of dark patches of Border Collie's coat. An offspring inherits 1 patch color gene from each parent. Each parent has 2 color genes, and the offspring has an equal chance of inheriting either one. Now the dominant gene, B, is for the black patches, and gene R is for the red patches. Any gene combination with the dominant gene would result in black patches. So if we have any combination with a black patch gene, that offspring is going to have black patches. Suppose each parent has the same gene combination, they have the dominant gene and the secondary gene, little r for red patches. The Punnett square, we definitely want to be able to draw a Punnett square. It's my understanding you do these in biology with Mr. Culver. The Punnett square shows the possible gene combinations of the offspring and the resulting patch colors. So if these are the two parents, and this is kind of like the table method of multiplying polynomials we learned in the last video, B and B is B squared, or BB, B and R, BR, down here B and R, BR, and in the bottom right-hand corner we've combined the two recessive genes R and R, okay? What percent of possible gene combinations result in black patches? Well, let's look. First of all, we have 4 possible combinations. I'll write them in here. 1, 2, 3, 4. Okay. This combination is going to be black patches. This combination has a black patch gene. So does this one. 3 out of the 4 combinations have a black patch gene, which means there's a 75% chance that our dog would have black patches. Okay, now the next question. Show how you could use a polynomial to model this. Well, it'd be easy. We're taking one dog, which has the B plus the R gene, and we're combining it with the second. Do you notice how this is a binomial squared? That's one of the special shortcuts. This is the 3-step shortcut. Take the B gene and square it. That's the first. Take the small r gene and square it. And if we multiply these together, BR, and double it, we get 2BR. Okay? So if you look, let me put a 1 in front, there are 3 gene combinations that have a BR and 1 doesn't. This is 3 out of 4, just matching here. Okay? So either way we do it, if we draw a Punnett square or if we do as I did here, you're going to see 1 combination and 2 more. 3 out of the 4 combinations are going to give me, 3 out of 4 is 75%. I have a 75% chance of having my dog with black patches. I think we're going to pause the video here. If you have any questions, make sure you ask during class.